In today's video, we will talk about multithreading and race condition. Thread is instruction or code, which is currently executed by CPU. Consider non-threading application with 3 threads. Each of the thread is handled by CPU in sequential manner. That is, after completion of one thread, other will run. Now in multi-threaded application threads, we'll share the CPU based on scheduling algorithm, giving illusion of parallelism that threads are running simultaneously. Now, let us see in code how to do it. In this code, we're demonstrating the basics of multi-threading using POSIX threads in C. The core of the program lies in the main function and the mithread function. Inside main, we create 2 threads using pthread_create. Each thread is given a label, either A or B. Both threads are assigned to run the same function, myThread. This function prints its label along with a step count 5 times and pauses for 1 second between each print to simulate doing some work. Meanwhile, the main thread waits for both threads to finish using pthread_join. When we run this code, the output is consistent. But now, let's slightly change the code. We introduce a global variable and make the mithread function increment it. When we run this updated code, we notice that the value of the counter changes every time. Why? Because both threads are incrementing the same shared counter variable without any synchronization, leading to unpredictable results. To understand why this happens, we need to look at how threads and memory work. Every thread has its own private memory stack and are not shared between threads. When the CPU switches from one thread to another, say from thread A to thread B, it saves thread A's state. Thread A starts incrementing the global counter. It reads the value and adds 1, but before it can write the result back to memory, the CPU switches to thread B. Now, thread B also reads the same old value, adds 1, and writes it to memory. When thread A resumes, it completes its write, but now it overwrites what thread B just did. So, even though both threads executed the increment code, the counter only increases once. That's the bug. It's called a race condition, because both threads are racing to update the same variable, and whichever one writes last ends up silently erasing the work of the other. It doesn't crash. It doesn't give a warning. It just produces the wrong result. And that's what makes race conditions so dangerous. We will solve our race condition in the next video and try to understand atomic operation and mutex.